Hello everyone, I'm Vikram P. Maduri here. I'm a software architect, and in this session, I'm going to discuss with you all the deep learning overview as well as a couple of frequently asked questions, whether it might be to know the technology or to prepare for the interviews as well. So now, outline of this session would be like machine learning basics. See, what exactly we would be discussing in this coming sessions is like the machine learning basics, which I already had uploaded that session in YouTube channel, youtube.com/Softech. You can follow it up and check it out. An introduction to deep learning is what we're going to discuss now. What is deep learning? Why is it useful? Main components, hyperparameters, like activation functions, optimizers, cost functions and training, regularization methods, tuning, classification versus regression tasks, DNN basic architectures, convolution, and recurrent attention mechanism, application example in relation extraction. And what we are not going to discuss is the backpropagation, GANs, and Bayesian deep learning, and kind of those stuff. Yeah. So machine learning basics. Machine learning is a field of computer science that gives computers the ability to learn without being explicitly programmed. So in normal training, we have the labeled data. We send that labeled data to machine learning algorithm, and the machine level algorithm in turn will generate the learn model, and then we have the prediction. So we have in the prediction we have the label data as well, so that will also be uh, mapped to learn model, and then we'll get the predictions. So methods that can learn from and make predictions on data. Then types of learning. What are the types of learning that we have? We have supervised learning with a labeled training set. Example, email classification with already labeled emails, etc. Supervised, discover patterns in unlabeled data. Example, cluster similar documents based on text, etc. Now, reinforcement learning is all about acting based on feedback or reward. So example, learn to play, go, reward, win or loss, kind of these kind of things. And then we have the basic classification of data, like anomaly detection, sequence labeling. We have text, and that text can be analyzed as class A, and then we have the regression. Regression can be designed, and then we have the clustering of the data. So here we have the machine learning versus the deep learning. Most machine learning methods work well because of human design representations and input features. For instance, like machine learning becomes just optimizing weights to best make a final prediction. And let's assume that let's consider a particular machine learning in practice, where we have the describing your data with features a computer can understand, and learning algorithm. So we have domain specific, requires PhD level talent in describing your data with features a computer can understand. So then we have the optimizing the weights on features. So current word, previous word, yeah, we can do a current word, previous word, next word, and current word character engram, and we can do surrounding POS tag sequence, current word shape, surrounding word shape sequence, presence of word in left window, presence of word in right window, etc. Now, what is deep learning? A machine learning subfield of learning representations of data, exceptional effective at learning patterns. Deep learning algorithms attempt to learn at multiple levels of representation by using a hierarchy of multiple layers. If you provide the system tons of information, it begins to understand it and respond in useful ways. Now, let's consider an example wherein we have the deep learning is used in a scenario where we have a car, and car has been a feature extraction. A person an individual is sitting there and operating that, and we have the classification, and then we have the output of the car. I mean, like, we will be analyzing whether it is a car or not a car. So we are just analyzing this. The input is an image of a car, and we are analyzing it, and we are mentioning whether it is a car or not a car. So there is some classification going on in the mind. So same way in the deep learning, what happens is like you have the image, then the deep learning decides whether it is a car or not a car, and it will give you an output whether it is a car or not a car. So this kind of this kind of feature is available only when we have huge amount of data being supplied to the it's supplied to the deep learning system, and then it will start analyzing and comparing the input with the existing data. Why is deep learning useful for? Manually designed features are often over specified, incomplete, and take a long time to design and validate. Learned features are easy to adapt, fast to learn. Deep learning provides a very flexible, almost universal learnable framework for representing world, visual, and linguistic information. So it can learn both unsupervised and supervised data, an effective end-to-end joint system learning, and utilize large amounts of training data. Why is DL useful for? In 2010, deep learning started outperforming other machine learning techniques, first in speech and then in vision, then in NLP, the natural language processing. And we have the start of the art in, like, for example, like deep learning in speech. It was like, according to the Microsoft speech group, we had something like there is a particular graphical representation where we have a using of DL has been introduced around 2010 for analyzing the voice. The image is of the error rate, so the error rate is being reduced drastically when we have used the deep learning concept for the voice recognition. So several big improvements in recent years in natural language processing. We have machine translation, sentiment analysis, dialogue agents, question answering, and text classification. Leverage different levels of representation, words and characters, syntax and semantics. We have a neural network introduction. So in this I'm going to discuss in another session. So here we have the input, and we have this processing, and then we have the output. So in the input we are giving some x, and we get the output as y. So we have a process here. For that we have the logic to be written, and it should be like programmatically managed. So we have 4 plus 2 is equals to 6 neurons, and not counting inputs. So we have 3 into 4, that's 12, plus 4 into 2, that's 8. So this 12 plus 8 would be 20 weights, and 4 plus 2 is 6 biases. So 26 learnable parameters would be coming up in this particular scenario where we have 3 inputs. So we have the activation functions, and we have the weights. So how do we train this? Now the training, sample label data, forward it through the network, sample label data, batch, and forward it through the new network, get predictions, back propagate the errors, update the network weights. We have optimize minimum or maximum objective cost function, and generate error signal that measures difference between predictions and the target values. So use error signal to change the weights and get more predictions. So subtracting a fraction of the gradient moves up towards the local minimum of cost functions. So we have a tangent line, and we have a slope, and we basically have this momentum and add grade and all this stuff is there. So we are actually predicting those from the training. So we are basically supplying different information for the training of data. So we have something like gradient descent. We have objective like a cost function, and then we have theta j new and theta j old. Theta j new is equal to theta j old minus alpha d by d theta old j into j of theta. So updated each element of theta. So theta new is equals to theta old minus alpha v the delta theta j theta. So that will be the learning date. So recursively apply chain rule through each node. So basically for this, we have the adaptive grade, and this adaptive grade, what exactly that maintains a per parameter learning rate, so that improves the performance on problems with sparse gradients, example like natural language and computer vision problem. So root mean square propagation, so that's it's also popularly called as RMS prop. That also maintains a per parameter learning rates that are adapted based on the average of recent magnitudes of gradients for the weight. Example, how quickly it is changing. This means the algorithm does well on online and non-stationary problems. Now Adam realizes the benefits of both AdaGrad and RMS prop. Instead of adapting the parameters learning uh, rates based on the average first moment as in RMS prop, Adam also makes use of the average of the second moments of the gradients, the uncentered variance. So specifically, the algorithm calculates an exponential moving average of the gradient. I repeat, exponential moving average of the gradient and the squared gradient. So we have the moving average of the gradient and squared gradient and the parameters beta 1 and beta 2. Values close to 1.0 result in a bias of moment estimates towards 0. This bias is overcome by first calculating the biased estimates before then calculating biased corrected estimates. This is all done in the local gradient here. We have this option here. Now one forward pass. So text input representation, we have TF, IDF, word embeddings. So we have these are the various numbers we have, and then we have this is W, say W, this is XI, this is about a point 2, point 1, point 2, point 3. This is XI values, and plus we have B 1.0, 3.0, 0.025, and 0.0, and all these like when we multiply W into XI plus B. Here we are writing it as XIWB. So we have very positive and positive, negative, very negative. So whether we can decide whether whether it is very positive or negative or very negative. What would be the output is what we can calculate based on the formula. So we have activation functions. We have non-linearities needed to learn complex non-linear representations of data. Otherwise, the NN would be such a linear function. So we have 3 hidden neurons here. Here we have the 6 hidden neurons, and we have here 20 hidden neurons. So I'm going to explain you in detail from here in the coming session. Thanks for watching this video, and do subscribe to our channel. Thanks for watching this video again, and catch me up in the next session. I'm going to release a next session very soon. And if at all, if you like this video, do subscribe to our channel www.youtube.com/Softech. And if at all, if you are looking for trainings on AI, ML, or DL, you can contact us at info@jsofttech.com. Thank you. Have a great day.